Hey everyone, so today we're going to talk about A2A, Agent to Agent Protocol by Google and Linux Foundation. So this is an example which I'm giving. You've got a sales bot and it's trying to close the sale, but it can't tell the inventory bot to update the stock without a human playing the middleman. So that's the era of isolation. So the sales bot is powerful, the inventory bot is powerful, but they can't do anything. So Gartner predicts that by 2026, 40% of enterprise apps will use AI agents. And probably you're already seeing this, which is a huge jump from less than 5% in 2025. The speed with which AI is going, things will change very fast. But without a standard protocol, these agents are trapped in vendor silos. That means customer integration nightmares for anyone trying to build a complex workflow. So that's where A2A or agent to agent protocol comes into picture. It's developed by the Super Interoperability Alliance. So Google came up with this protocol and then they gifted it to the Linux Foundation. So it's kind of open now for anyone to use. So this is what they claim as the universal link system for AI agents. It's a vendor neutral open standard designed to let agents share tasks autonomously across any platform. You can think of it as the connective tissue for collaborative intelligence. How do they do it? So they use an agent card. So every single agent will have this card and it might be hosted at a well-known URL, which kind of is basically an agent.json at the end of the day. And what does it list? It lists an identity, which can be like a name and version, capabilities, can it handle text, audio or video, authentication, how it logs in, like OAuth 2.0 or API keys, and skills, specific tasks like code generation or data analysis. So in this A2A world, agents play two roles whenever they are talking to something. So the client, you can assume it as the quest giver in this fantasy land, and the server, specialist who executes this task. And these roles are flexible. So the agent can be client for one task and a server for the next. So it doesn't mean that there's only one person who's going to delegate these things. It can be multiple people. And how do they do it? They can communicate via the Synapse link. So there's a standard web tech like HTTP, HTTPS, and JSON RPC 2.0, and you don't need any proprietary networks to deal with this. Now we can go more detail in how this works, but right now I'm keeping that minimal, and we can learn about it in different places. So, and when the work happens, just think of it like the Docker container. So it's wrapped in a task object. This is a structured unit of work that contains instructions and data parts like text files or raw data. Once the specialist agent finishes the job, it returns an artifact or like whatever it was needed. And some of you will be thinking, well, we already have MCP. Why do we need an A2A? So MCP came a little before A2A. So obviously it's more popular. MCP, which is also called Model Context Protocol, it gives agent tools. We call it vertical integration, and A2A gives an agent or teammates horizontal integration. Now there is a simple difference between tools and agents, where tools are like a particular task you're doing, and an agent can do a little more broader task. And as you kind of expand the capacity of these tools, they come closer to what an agent can do. And similarly, if it's more specific for an agent to do, it will become more like a tool. So you can use interchangeably how you want, but think of it as one of the ways to do this, to get this done. And that's where there's so much options to do when you're using an AI to solve these problems. But I'm just saying that you don't have to use MCP for everything, and you don't have to use A2A for everything, and you can use this similarly separately as well. So there's a real world example. So imagine you're booking a flight. A booking agent uses A2A to call a flight search agent, and now this uses an MCP tool to find a list, and it calls a payment agent to finish the job. So all this happens without the human glue code. Agents find each other using Recruitment Radar. They query a discovery service and use LLMs to match capabilities in agent cards. So let's say you have multiple agents, but you do not know which one to call. So you look at the cards and they'll use this Recruitment Radar. So basically no hard-coded lists are allowed. So I'm not very sure how it exactly works, but this is what they claim. So of course it's all not sunshine and rainbows, because you can use A2A. We have to watch out for some problems. So one of them is agent session smuggling. So this is where malicious agents might inject hidden instructions. So you will say something, it will give back, and then suddenly ask like, oh, I need your password, and it will take the password, and now you're hacked, something like that. And then there's the n square connectivity problem. What does that mean? So you're starting with one agent, you talk to two agents, some 4 agents, 6 agents, 8 agents, and suddenly when there's way too many, it will take way too much time to figure out which agent to actually call. So the AI can get overwhelmed with all the resources that it has. But despite of that, it's kind of interesting how the future is looking. This is kind of like an economy of agents using micropayments. You can use the 402 protocol and ledger anchored identities for trust. I don't know what this means. I'm just naming what I've learned so far. So basically we are moving toward an autonomous organization where you can literally have your agent call my agent to get business done. This will take time to get to a point where you can just relax and have coffee and do all your agent works. You'll probably have to do work way more than that, but isn't like a good future to have. So let me know what you think about, if you understood anything from this video, and if you have any feedback, please let me know. I'm always looking to improve. So thank you so much.